Okay, welcome to lesson 9, more representing proportional relationships with equations. And yeah, so some of the things I'd like you to continue to come away with concerning the constant of proportionality is I want you to go ahead and use that constant to represent proportional relationships by equations in real-world contexts. Okay, and we're going to do this in relation to equations and their corresponding ratio table and graphical representations, which are, our graphs. Okay, our coordinate graphs. Okay, so as you can see, first thing we have here is we have example 1. Jackson's bird houses. Okay. In this lesson, we're going to have you start writing equations in two variables. Okay, writing your own equations. You're going to analyze this data, and this will help you understand this constant of proportionality and how to write equations with two variables. Okay. And we will now and then, like we did last lesson, connect the graphical representation, which is the graph, and something we call the tabular representation, which is the table. And we have to model those side by side, and we have done that. Okay, so once again, here is our example 1, Jackson's birdhouses. I'll read it, and then you'll see here you have, let me read it first. So, Jackson and his grandfather constructed a model for a birdhouse. Many of their neighbors offered to buy the birdhouses. Jackson decided that building birdhouses could help him earn money for his summer camp, but he is not sure how long it will take him to fill all of the requests for these birdhouses. If Jackson can build 7 birdhouses in 5 hours, write an equation that will allow Jackson to calculate the time it will take him to build any given number of birdhouses. So Jackson's done a little data gathering himself. Obviously, he has built 7 birdhouses in 5 hours. Maybe this was one order he had to fill, or just doing it for his family. And now he's thinking, hey, I can do this for some good money to help me pay for my summer camp and beyond. Very industrious thing to do. Highly recommend you girls and boys give projects of this nature a go yourselves. Okay, so here we go. We have Jackson. He knows he can build 7 birdhouses in 5 hours. So what I want you to do with that data, okay, with these two bits of information here, 7 birdhouses, 5 hours. You guys thinking ratio? Mm-hmm. I want you to go ahead and write an equation. So here we go. A is write an equation that you could use to find out how long it will take him to build any number of birdhouses. And that's this idea of equations. And they are formulated so that you can predict things of this nature. So for any number of birdhouses, if we have our original data, how long will it take to build any number? Okay, and B is asking you how many birdhouses can Jackson build in 40 hours. Now I want you to apply, knowing one of those variables, okay, the 40 hours, how you can apply it back and apply it to calculate your birdhouses, of course, using your rate, okay, that you're going to come up with. Number C asks you how long will it take Jackson to build 35 birdhouses. Now we're working the other way, okay. Now we have birdhouses. We're going to move towards the hours, okay, and using, again, our rate to help us out. Okay? And save this here. And let's just go ahead and I just wanted to scroll down here a little bit. D then asks you how long will it take to build 71 birdhouses. Okay, so use the equation from part A, again, to solve this problem. Okay, so using that equation that you create in A to solve all these different parts, A, B, C, and D. So go ahead and take as much time as you need to do this. Pause the presentation first and come on back. Okay, now I created a table here. Just wanted to get started. And first question, though, for you is, in this case, in this problem, does it matter which of these variables is independent or dependent, truly? And I would tell you, I would say no. Okay, you may argue otherwise, and and you may be right, and you may have a way that you think would be best. But I will tell you one thing, though, that I have learned in the past, and I have recommended, is that you actually use that y-axis as your dependent, of course, and that is what it always is, the y. But also this y-axis, as it is the dependent, okay, variable, that dependent variable is usually that variable that is measured, okay? And in this case, I mean, to be honest, I mean 7 birdhouses, that's a measurement, that's a number of birdhouses. But I'm talking in terms of a measurement such as length and weight and number of hours, for example. So I would recommend that you go ahead and make this the measurement your dependent variable. So that's why I have decided to put the number of hours here over in the y column. Okay, so if we go ahead and write an equation, as number A asks us, for how long it will take to build any number of houses, we could write it this way: y equals. Now remember, the rate here is y is a function of x, so therefore it's going to be 5 over 7. So y equals 5/7 x. Or, if you wanted to use variables b and h being hours, so hours equals 5/7 b. Okay. So we can find out how long it will take to build any number of birdhouses by plugging in number of birdhouses into our formula. Okay. Now B asked, how many birdhouses can Jackson build in 40 hours? This is a little bit different. We are trying to focus up top. We're focusing on figuring out how many houses he could make in any number of I mean, how many? Up here we're trying to figure out the hours. Okay, so we're solving for the hours. Therefore, we have hours on one side and isolated. Okay, so down here, for how many birdhouses Jackson can build in 40 hours, it's very important that we have our variables in the right places. Now, when we try to figure out this B, how many birdhouses can Jackson build in 40 hours, there are a few different ways to do it. We talked before, I think in a prior lesson, about doing it arithmetically, okay? Because if we looked at it here, we could say 40 hours here, okay? This 5 over 7 ratio that we created here is equal to 40 over, we could solve here for x, okay? So we can indeed do it this way here. And the way hopefully you know with your fractions you're finding relationships. So how is 5 related to 40? And that's multiplied by 8. And then whatever you do to that top, you need to do to the bottom as well, the numerator and the denominator. And if we go ahead and multiply this by 8, we would get 56. So we would know that 5 over 7 is the same as, equivalent to, proportional to 40 over 56. And this 56 would be our x value, and that would go here. Okay, so we can check it that way. Now when it comes to doing this algebraically, we'll go back to what we did last. I kind of introduced you to this. We could use our formula here, h equals 5/7 b, and we could plug in what we know. And what we know here is 40. We know the hours equals 5/7 b. Okay, and I'm just going to continue down here, likewise should, over on top, and I'll just erase it later. So, and the way we isolate this b over here, again, like I had told you before, is that we divide by the 5/7, so 5/7 b, and we go ahead and divide that by 5/7. Now that's, and what we do to one side, we do to the other, the same way as we did. We have to manipulate fractions in a similar way. Okay, we would divide that by 5/7. Okay, so when you do this, of course, you're going to divide the 5/7 by 5/7. That's of course going to be 1. Okay, so we're going to get b on this side. Okay, so now we're going to solve for b. But over here, again, when we are dividing 40 by 5/7, okay, we're going to change our 40 into a fraction, which is always just 40 over 1. And remember, when we divide by any fraction, what we can do more easily is to multiply by its reciprocal. Okay, so 7 over 5. Okay, so we're multiplying 40 over 1 times 7 over 5, and that equals 280 over 5. And then if you did this division, you would get 56. So 56 equals b, or b equals 56. So this is the algebraic way to solve the problem. Over here is our arithmetical way to solve it, right over here. Again, both are good. It's always good if you feel comfortable with the arithmetical way, check it that way, and then do it also algebraically. Okay. Now see, even though I've written all over here, I'll read it from another source here. So how long will it take Jackson to build 35 bird houses? Okay, 35 bird houses. Hopefully you have all this written down. If you don't have all of this mess here written down, you can write it down in your binder there, or you can write it on another piece of paper. Pause this if you want. You can write all that down, because I am going to now erase it. Okay, so I'm going to erase this big mess here. Okay, there's all that, and then we're get rid of this too. Okay, and now we're going to solve. So over here we could add, we did that one then already, right? And of course our rate is always still the same. It's 5 over 7, okay, or 40 over 56, which is the same. Okay, so now we're to build 35 birdhouses, again applying our formula here. H equals 5/7 b, and then if I'm going to do H equals 5/7, and I'm going to multiply that by the 35, okay, and when I multiply, I want to just go ahead and change that into a fraction, which makes it so much easier. Multiplying fractions, of course, is an absolute breeze in this sense. Not as easy to understand what we're doing, but it sure is easy to do. Okay, and what is that? 175, right? 175 over 7. Okay, so that's what this is. 175 over 7. If we do that division, then what do we get? We get 25. Okay. All right. So H equals 25. So when we knew the number of bird houses, which were 35, our number of hours is now 25, and that 25 over 35 is going to be the same proportional equivalent to 5 over 7, because our rate is staying the same. Okay? Okay, so D asked, how long will it take to build 71 birdhouses? Okay, and again, using the equation to solve for that, 71 is looking a little sloppier than 35, huh? Not going to be as neat. Let's go ahead and do it. Okay, and so we're going to go ahead again and plug in here. So now we still know we have 71, because that's the number of houses, equals 5/7 B. I'm sorry, this is wrong here. Beep. Excuse me. We know the birdhouses. Okay, excuse me. So H. Okay, so how long? We're trying to find out how long it'll take. H, which is hours. I'm sorry, houses, birdhouses, blah. Anyway, H equals 5/7 B, and we know our B, of course, is in this case 71. All right, so then H equals. Actually, what I'm going to do here, let me do this way. We should be doing this here. We should have a little bit more room. So I'll start up here. H equals 5/7 B. H equals 5/7 times 71 over 1. H equals 355 over 7. Okay, and again, this one I'm using H and B. Okay, because it's kind of easy. Of course, I could have also used Y and X. Okay, which are going to be more frequently seen. Okay, and yes, so if we do that and we did our division here, we get and again, if you're using a calculator, that's fine. If you need some work with this, do it. Okay, it's very much worth it. So 50. Okay, 35, and then we got 5, and up here 50, and what do we get here? We end up with that's 7, 50. This is 0 here. 50.7. 50.7. So if we look at 50.7, so this is what we get, and 49 and 1, and that doesn't, we don't need to worry too much about this, okay? But we have 50.7 hours, okay? Now 50.7 is all well and fine, and is indeed 50.7 hours is indeed an answer, but when we're dealing with time, we want to be more specific. So this 0.7 here, this is what we need to work with, okay? The 0.7. Now, some of you, hopefully all of you, would know how to figure out 0.7 or 7/10 of an hour. What we do is we take our hour and split it into minutes, okay? And so we have 60 minutes in an hour, okay? And then if we want to find what 7/10 or 0.7 of an hour is, we would then multiply that times 0.7 times 0.7. Okay, and then I know that is 420. I get when I do this, but I know it's not 420 because I know this 0.7 is less than 1. So my answer has to be less than 60. Okay, so I know that this is actually 42 minutes. Okay, because 60 minutes times 7/10 of an hour, okay, is 42. Okay, so my more complete answer here would be 50 hours and 42 minutes. Okay, would be how long it would take to build 71 birdhouses. Okay? And hopefully you guys got something like that. If you didn't, and if you got the 50.7, that's fine, okay? But when we're just remember in the future when we're talking about something such as time, and we can indeed find exactly, specifically the time, we need to go ahead and do that.